Hello students, welcome to my channel Math Magic. Me Provish Sarkar. Today we will do the quadratic equation. This chapter is on your class 11 book. Okay, all of you share my videos and subscribe my videos if my videos helps your study. Okay, let's start quadratic equation. So first of all, what is quadratic equation? An equation write in the form of ax square plus bx plus c equal to 0. This is called a quadratic equation. Okay. Now after solving this equation by using formula, we get x equal to minus b plus minus root over of b square minus 4ac divided by 2a. Okay. This also name as Sridhar Acharya's formula. Okay. Now look at this, b square minus 4ac is called discriminant. Okay, in short we write capital D. B square minus 4ac is called discriminant of this equation. Now what is its function? So without solving any equation, we told that the nature of the roots of that equation using discriminant. Okay, but how? See, if number one, if discriminant greater than 0, that means the value of b square minus 4ac greater than 0, we get two real and unequal root. D greater than 0, we get two real and unequal root. Okay, now 2, if d equal to 0, okay, if d equal to 0, we get two equal real and equal roots. Okay, now case 3, if d less than 0, that means discriminant less than 0, so we get two imaginary roots. Okay, I repeat this function. If d greater than 0, we get two real and unequal root. If d means discriminant, d equal to 0, we get two real and equal root. If d less than 0, so we get two imaginary roots. Okay, now let relation between roots and coefficient of this equation. Okay, now the relation between the coefficient and roots. Okay, now see, if the relation between roots and coefficients, if the roots of the equation ax square plus bx plus c be alpha and beta, two roots be alpha and beta. If after solving this equation we get two roots be alpha and beta, so sum of the roots, that means alpha plus beta, is equal to minus b divided by a. That means minus of coefficient of x divided by coefficient of x square. Okay, now product of the roots, that means alpha beta, is equal to c divided by a. That means constant part or constant term divided by coefficient of x square. Okay, this is the relation between roots and coefficients. Okay, now another formation of a quadratic equation when two roots are given. Okay, formation of a quadratic equation when two roots are given. Suppose two roots be alpha and beta. This is given. Now the quadratic equation is x square minus sum of the roots, that means alpha plus beta, into x plus product of the roots, that means alpha beta, is equal to 0. Okay, now I repeat again, when two roots are given in a quadratic equation, that is alpha and beta, so sum of the roots equal to minus coefficient of x divided by coefficient of x square, and product of the roots, that means alpha beta, equal to constant term divided by coefficient of x square. Okay, now formation of formation of an quadratic equation when alpha beta, that means two roots are given, the equation is x square minus alpha plus beta into x plus alpha beta equal to 0. That means x square minus sum of the roots into x plus product of the roots equal to 0. Okay, now come to examples. Okay, now see example number 1. Here is a given quadratic equation, that is given, find the nature of the roots. Okay, the equation is 4x square minus 4 root 3x. Example number 1. The equation is that is given 4x square minus 4 root over 3x. 4x square minus 4 root over 3x plus 3 equal to 0. That is given. Okay. Now the question is discuss the nature of the roots. So all of you already discussed. I already discussed how to solve the nature of the roots or how to get the nature of the roots. First of all, we find the discriminant. How to find discriminant? Again, you see x equal to, by using formula, x equal to minus b plus minus root over of b square minus 4ac divided by 2a. Okay. So b square minus 4ac is called discriminant. B square minus 4ac is called discriminant. So here the equation, look, here the coefficient of x square, that is called a, coefficient of x minus 4 root 3, that is called b, and constant term, that is 3. So discriminant equal to d indicated at d. Okay, so discriminant equal to b square minus 4ac. So b square, b means minus 4 root 3, b square minus 4ac, 4 into a, that is 4 into c means 3. Okay, so 4 4 is 16, 4 square means 16 and minus become plus, minus minus plus, 16 into 3 48. Okay, minus 4 4 is 16, 16 into 3 48. So 0, we get the result is 0. That means discriminant of this equation we get 0. So what does it mean? 0 means we get, after solving this completely, after solving the complete equation, we get the two real and equal root. Okay. So just seeing the discriminant, we told the nature of the roots. Okay. See carefully. Come to the next sum. Example number 2. Okay. Next example, listen the question first. Next example, example number 2 is alpha and beta be the roots of the equation ax square plus bx plus c equal to 0. Okay, alpha and beta be two roots that is given in the question. Okay, so ax square plus bx plus c equal to 0, alpha and beta be two roots. Find the value of alpha square plus beta. Find the value of alpha square by beta plus beta square divided by alpha. Okay, find the value of this one. Okay, now see, first of all we find alpha plus beta, that means sum of the roots. Alpha plus beta equal to minus b divided by a. Okay, now alpha beta, that means product of the roots, equal to c divided by a. Okay, now put this value, put this equation, that means alpha square divided by beta plus beta square divided by alpha. Okay, now see, do the LCM. Alpha beta is the LCM. Here is alpha cube plus beta cube. Okay, now the put the formula of a cube plus b cube. So all of you know the formula of a cube plus b cube. So a cube plus b cube means a plus b whole cube minus 3ab into a plus b. So here is alpha plus beta whole cube minus 3 alpha beta into alpha plus beta whole divided by alpha beta. Okay, now put all the values of alpha and beta. So alpha plus beta equal to minus b by a whole cube minus 3 alpha beta. 3 alpha beta means c by a. Okay, into alpha plus beta, that is minus b by a. Okay, divided by alpha beta, that means c by a. Clear everyone? Now calculate. Here we get b cube minus b cube divided by a cube minus plus 3bc divided by a square, 3bc divided by a square, and here is c divided by a. Okay, now do the LCM. LCM is a cube is the LCM, so a cube is the LCM, and here is minus b cube plus 3abc into, here is c by a and reciprocal it a by c. So finally we get the answer is minus b cube plus 3abc divided by a square. Okay, I repeat, a square c. Okay, so finally we get the answer, that is minus b cube plus 3abc divided by a square into c. Okay, see carefully. Next, come to the next one. Next question is form an equation. Next question is question number 3. Form an equation whose one root is 1 by, example number 3, form an equation whose one root is 1 by 1 divided by 3 plus 2 root 2. 3 plus 2 root 2. Okay, this is one root. So first of all rationalize it. Okay, multiply numerator and denominator by the conjugate of this. That means 3 minus 2 root 2 divided by 3 plus 2 root 2 into 3 minus 2 root 2. Clear? Okay. Now here is a plus b into a minus b. So we get 3 minus 2 root over 2 divided by a plus b into a minus b. All of you know the formula, a square minus b square. So a square means 3 square. 3 square means 339. Okay. Then minus 2 root 2 whole square, 2 to the 4 to the 8. 2 root 2 whole square means 8. So we get 3 minus 2 root 2. Okay. Now see, when we form an quadratic equation, if one root is given 3 minus 2 root 2, so another root or second root must be 3 plus 2 root 2. Okay. One root is then another root must be 3 plus 2 root 2. Clear everyone? Okay. If one root be a plus root over b, then another root must be a minus root over b. Okay. So here one root is given 3 minus 2 root 2. So another root is 3 plus 2 root 2. Okay. Now we need to find the sum of the roots and then product of the roots. Okay. Now see, sum of the roots equal to 3 minus 2 root 2 plus 3 plus 2 root 2. So we get 6, and product of the roots 3 minus 2 root 2 into 3 plus 2 root 2. Okay. So here is a plus b into a minus b. So what is the formula? A square minus b square. So a square means 3 square, that is 9, minus 2 root 2 whole square, that is 8. So we get 1. So sum is 6 and product is 1. So the quadratic equation is all of you know the formula, x square minus sum, that is 6, sum of the roots x plus product equal to 0. Okay, this is the quadratic equation. Okay, so this is another important sum. One root is given, another root is this. So first of all find the sum of the roots, then find product of the roots. After that we get the equation, quadratic equation. This is the required answer. Okay, see carefully. Now come to the next one. Question number 4. Example number 4. See carefully. Example number 4. First of all, listen the question first. Okay. Question number 4. The question is, if the roots of an equation ax square plus bx plus b equal to 0, ax square plus bx plus b equal to 0. Okay, if the roots of the equation ax square plus bx plus b equal to 0 are in the ratio p is to q, P is to Q. Okay, two roots are in the ratio that is given P is to Q. Okay, now the question is prove that root over P by Q plus root over Q by P equal to, so required to prove are TP, required to prove root over of P by Q plus root over of Q by P equal to root over of B by A. Okay, so a quadratic equation is given, that is ax square plus bx plus b equal to 0, and two roots are in the ratio P is to Q, required to prove root over P by Q plus Q by P equal to B by A. Okay, now see how to solve this sum. Very important. Okay, let the two roots be, let we take two roots b alpha and beta. Okay, we took two roots b alpha and beta. So alpha plus beta equal to minus b divided by a. Acha, alpha beta equal to b divided by a, and alpha divided by beta, that is ratio, p by q, that is given. Okay, so we get three data, that is alpha plus beta equal to minus b by a, alpha beta equal to b by a, and alpha by beta, that is p by q. Okay, now see, alpha beta equal to p by q. Now see, required to prove root over p by q plus root over q by p equal to root over b by a. Okay, now see, root over p by q plus root over q by p whole square. Okay, we find the square of this one. So we get a plus b, using the formula of a plus b whole square, a square, that is p by q, root over p by q whole square, that is p by q. Okay, a square plus b square. B square means root over q by p whole square, that is q by p, then plus 2ab, that means 2p by q into 2 root over q by p. So root over p cancel, root over q cancel. So we get only p by q. So p by q equal to alpha by beta. Okay, plus q by p, that is beta by alpha. Okay, plus 2. Just put the value. Okay, after that do the LCM. Alpha beta is the LCM. Here is alpha square plus beta square plus 2 alpha beta. We get the result alpha plus beta whole square divided by alpha beta. Okay, now put all the value. Alpha plus beta, that is minus b by a whole square, minus b by a whole square. Okay, divided by alpha beta, that means b by a. Okay, now b by a whole square divided by b by a. So we get b by a, b divided by a, and minus whole square become plus. Okay, now here is root over p by q whole square, root over p by q plus q by p whole square equal to this one, b by a. So just omitted the root over, that means square root on both sides. We get root over of p by q plus root over of q by p is equal to root over of b divided by a. Okay, root over of p by q, root over of q by p equal to root over of b by a. Okay, proved. Look, very important sum. This is very important sum. See carefully. Okay, now come to another example. Okay, example number 5. See carefully. See carefully. Example number 5, listen the question first. Example number 5, listen the question first. If the equations x square plus ax plus b, if the equations x square plus ax plus b equal to 0, and another equation x square plus bx plus a equal to 0. Okay, so we get two equations, x square plus ax plus b equal to 0, and x square plus bx plus a equal to 0. Have a common root. Okay, have a common root. Then prove that a plus b plus 1 equal to 0. Prove that a plus b plus 1 equal to 0. I repeat the question, listen carefully. Here is two equation is given, there is a common root. So prove that a plus b plus 1 equal to 0. Okay, let's start. How to solve this? See carefully. Okay, let the common root in these two equation we take alpha. Okay, so alpha common root. So we write alpha square plus a alpha plus b equal to 0, equation number 1. And again alpha put on equation 2, second equation, that is alpha square plus b alpha plus a equal to 0, equation number 2. Okay, now look at these two equations. By using elimination method, we get, by using elimination method, subtracted, sub, that is subtract these two equations. Change the sign, minus, here is also minus. So alpha square cancel. So we get a alpha minus b alpha plus b minus a equal to 0. Okay, now see, take alpha as common. Here is a minus b minus 1 take as common, so a minus b equal to 0. So a minus b take as common from the whole, so we get alpha minus 1 equal to 0. Okay, so a minus b into alpha minus 1 is equal to 0. Okay, now these two, product of these two number is 0, then one of them must be 0. So a b equal to 0, otherwise alpha minus 1 equal to 0. So we get alpha minus 1 equal to 0. So what is the value of alpha? Alpha equal to 1. Okay, what is the value of alpha? Alpha equal to 1. Now alpha equal to 1, put the value of alpha in any of these two equation. Okay, so we put the value of alpha in equation 1. We get alpha square, that is 1 square, plus a alpha, that means a into 1, plus b equal to 0, or we get the result a plus b plus 1 equal to 0. Proved. Okay, see carefully. Today up to this. Thank you, students.